Good morning, everyone. Today we're going to continue where we left off. We were graphing these two functions, and we just did the first one. Okay? So what do we see here? What we did last week? Okay, what we did last week is that we graphed these, we made the table. Okay, so that's a recap on that. Okay, we graph the function of 2 to the power of x, 2 to the power x, okay, by plotting the points. So we have seen some interesting phenomena here, right? First of all, we first plotted the points of -2. Excuse me, the input is -2, the output is 2 to the power of -2, which is a quarter. So let me make this font just a little bit larger so you can see the negative sign in the power. Okay, so we plotted the points. So we started with -2, and which is we get this point. Okay, so let me put on the so this point, when input is -2, the output is a quarter. And when input is -1, the output is 1/2, and that's the other point right there. When input is 0, the output is 1. So we get this point. When input is 2, input is 1, we get 1, 2. So this point right there. Okay. Let me do this again. So for 1, 2, it's right here. And 2, 4, when input is 2, the output is 4. And that point goes right there. Okay, so that's pretty obvious. Okay, and 3, 8. 3, 8 is way above. So we got these points plotted and we connected the dots and we got the curve for 2 to the power of x. 2 to the power of x. Okay, so that's what we did last time. Okay, all the points plotted. And in particular, we look at in the other direction, right? We look in this other direction. When x is, say, -10, of course, it's off the, it's not in the graph right now, but when x equals to -10, the output is 1/2 to the power of 10, which is a very, very small number. It's a very, very small, very, very close to 0, but it's larger than 0. So that point is way over there. And if the input is -1000, the output is going to be even smaller. So what we demonstrated here is that in this direction, as x is approaching -infinity, so let me put the comment here. When x is approaching -infinity, the power 2 to the power of x, 2 to the power of x is approaching 0, but larger than 0. Okay, but larger than 0. So we put a little positive sign to the shoulder. Okay, so meaning that 2 to the power of x is approaching to 0, but larger than 0. Okay, so that's the picture we got last time. So I'm going to put these comments on the top. Okay, so we done the picture, we plotted the points, we also have observed, okay, when x approaches -infinity, Okay, when x approaching negative infinity, okay, which is in that direction. X is getting smaller and smaller. The y value, okay, 2 to the power of x is approaching 0, but larger than 0. So it will never be 0, okay? That is, we're trying to say that 2 to the power x is always positive, okay, for any real number x. Okay, so that's what this picture tells us. This picture tells us that for x equals to whatever negative input, the output is always going to be positive. As x getting larger and larger, as you can see, the curve is going to be above x-axis always. In fact, the entire curve is above x-axis, which means that 2 to the power x is positive. It will never, ever touch this x-axis. Okay, so the curve of 2 to the power x, okay, never touches the x-axis. Okay, it never touches the x-axis, above x-axis. So that's what it means. Okay, that's what it means. Because this sentence is absolutely critical. Okay, and this sentence also expresses the domain and range. Okay, so this is another way to express the domain and range. The domain for 2 to the power x is all real numbers, right? Because from the table, you can see that the input can be negative number, can be 0, can be positive numbers. Okay. The domain include all the real numbers. Could it be fractions, decimals in between? Of course. So the domain for this function is all real numbers. Okay, all real numbers. And the range, which is the vertical span of the curve, the range is that 2 to the power x is larger than 0 for any real numbers. And domain and range in one sentence, domain and range together, domain and range together is that sentence. Okay, so that's what we did last time. And we graphed 2 to the power x, this exponential function, And next, we're going to continue to graph log base 2x. Okay, so what we're going to do is that we're going to do this in the same picture, right? So we have this picture 2 to the power x already here. Right, we already have this. And next we're going to work on this other one. Okay, this other one. And we will be interested in the domain and range. Okay, so we're going to plot some numbers. So next I'm going to set up a table and we're going to work on this together. Okay, we're going to work on this table together, right? Now, we're going to plot some points. We should have at least 3 columns, many rows, okay? So the input here for this function, which is log base 2x, okay, so that's our function. Our input, of course, is going to be, x. And the output, okay, the output is log base 2x. And input, output together. Input, output. Okay, so input x, output, of course, log base 2x. Okay, so I hope you guys are ready. Are you ready? Let's do it. Okay, so I'm going to give you some input numbers for you guys to calculate. Okay, the first number I'm going to give you is -1. The second one is 0. The third one is going to be 1. And the next one is going to be 2. I'm going to insert some more rows. And the next one is going to be 4. And the next one is going to be 8. So what we need to find out is what is log base 2 x of -1? And what is the log base 2 of 0? Log base 2 of 1, log base 2 of 2, log base 2 of 4, log base 2 of 8. Okay, let's see if you guys know how to fill out those numbers. Okay, what does that equal to? And can you give me those answers? So write down the table and you're going to start calculating on your paper. Okay, so have your paper pencil? Do you have your paper pencil with you? Please do that. Please do that. Okay, your paper pencil. So we're going to fill out this table after graph this guy. Okay, we're going to graph the other one. Okay, and we're going to make some adjustment. Okay, and, make this to be. I just adjusted the scale. Okay, so that's a 2 to the power x. Okay, that's 2 to the power x. And next, we're going to graph log base 2x. We're going to certainly use a different color. Okay, so you are going to give me those values. I need to make an adjustment to that point. 2 to the power x. Change it to 3, 6. Okay, so this curve is 2 to the power x. Okay, so next we're going to graph, we're going to plot the points. Okay, we're going to use red. We're going to use red. So what does, you can start with some numbers that we already know. For example, log base 2 of 1 is equals to, what does that equal to? Anybody want to offer an answer? Alan? Marcelo? Francisco? What is log base 2 of 1 equals to? Right, we have 1, 2, 3, 4, 5, 6. We have all these numbers, but I'm going to give you more. I'm going to give you some more numbers. Okay, I'm going to give you some more numbers. Insert more rows. Here. Okay, I'm going to give you a 1/8, 1/4, 1/2. Okay, log base 2 of 1/8, log base 2 of 1/4, log base 2 of 1/2. Okay, so you got more numbers to work with. 0. Very good. Thank you, Ellen. Okay, that's 0. So we got a point here. When the input is 1, the output is 0. Okay, so we're going to put that point on the chart, on the graph. Okay, I'm going to put that point on the graph. I'm going to put it as a red dot. 1, 0. Okay, and as we're getting more points, I'm going to put them on the graph. I'm going to put them on the graph. So what number would that be? Right, we start with the easy. Log base 2 of 2, that's equals to, and log base 2 of 4, 4 is 2 squared. 8 is 2 to the power 3. Hopefully that hint will help you. What is log base 2 of 2? Francisco? Marcelo? What is log base 2 of 2? Okay, you can look at the notes we did before, right? You can look at the notes we did before, right? Log base 2, all of that, right? Log base 2 of 2, log base 2 of 4, log base 2 of 8. We have done those, right? So now let's come back to complete the table. So what is log base 2 of 2? You can look at the notes that we have before, right? You can take a look at the notes we did before and think about, I know this weekend, maybe, you know, so what do we get? Come on, guys. Come on. When the input is 2, what is log base 2 of 2? Francesco? Marcelo? What do we have? Are you guys there? Okay, that's equals to 1. So we have input is 2, output is 1. Okay, and we're going to put this point on the graph. Okay, 2, 1, and that's a red dot right there. And how about log base 2 of 4? That's going to be equals to 2. So 4, 2. Input is 2, input is 4, output is 2. Okay, so we're going to put the next point on the graph. 4, 2, red dot. Okay, and log base 2 of 3, and that's going to equals to a log base 2 of 8, that's going to equals to 3. So the next point is going to be 8, 3. So we have another point on the graph. Red dot. Okay, so could you guys put these dots and mark them? And mark them, please. Okay, so let's mark them together. Let's mark them together. The first red dot is 1, 0. Okay, so it's 1, 0. 1, 0. Okay, so I'm going to put it as 1, 0. I'm going to use the red color. I'm going to use the red color. Okay, hopefully that will help. Let's see the position. 1, 0. The next point is 2, 1. 2, 1. So please mark your graph. Okay, 2, 1. Okay, So 2, 1, make it 2.1 here, 2.1, just 2, okay? It's a red dot. Okay, so 2, 1. And this is a 4, 2. Okay, input is 4, output is 2. So 4, 2. 4 is the input, output is 2. 4, 2. 4. Okay, it's gonna be a red dot, so we mark by red number. You guys follow? Okay, 4, 2. 8, 3. 8, 3. 8, 3. So 8, 3. 8 is the input, the output is 3. Okay, I'm going to use a red color. There. So all the 4 points are being marked. All the 4 points be marked. You may like to see, hey, look at that. There's a 0, 1 on 2 to the power x, and log base 2 x, you have a 1, 0. Look at these points, right? Look at these points. Isn't that interesting? And of course, we're not done yet. We're not done yet, right? So we have 1, 2, 3, 4 points already. Right? We have 4 points already. So what is the log base 2 of half? What does that equal to? Well, log base 2 half is 2 to the power -1. So the answer is a -1. So the next point is the input is half, the output is -1. Okay, so we're going to mark this point on the graph as well. And where would it be? It's going to be a red dot. Right there. Right there. Okay. Does everybody follow me? So can you put that point on the graph? Mark it. Okay, so let's mark that point. Okay, the input is 0.5. We can also use half. The output is -1. Okay, and that's a 0.5. Let me get 0.5. -1. Okay. I'm going to still use a red. Okay, that's 1 point. So I'm going to scoot over. I'm going to scoot that over a little bit. -1/2, -1. So that point, I'm going to make it to that way to see if that sees better. Okay. It's still not as good, but let me just move over a little bit more. Okay. There. Okay, it's better, right? So this dot. You can see the output start to be negative. Okay, so how about log base 2 of a quarter? What does that equal to? A quarter is 2 to the power of what? -2. So the output is -2. So input, output. So we have the input of a quarter and the output is a -2. And this point is going to be somewhere. It's going to be somewhere. Okay, so we're going to put that on the graph. I'm going to put that on the graph. Okay, so I just stretched the graph a little bit. Okay, so this way I hope we can see better. So a quarter, the output is -2. So this point, I'm going to make it right here, and of course it's still the red dot. Still the red dot and be marked. Okay, the output is -2. I'm sorry, the -2 doesn't look very clear, so I'm going to make it clear. Maybe this will help. Okay, so that's dot. Oh, we haven't put the dot in there yet. Okay, and that dot is going to be this point. It's a red dot. And that's the point where the input is a quarter, the output is a -2. Okay, so now how about 1/8? What will be the output for log base 2 of 1/8? Ellen, do you have an answer to that? Anybody else? Francisco, -3. Perfect answer. Perfect answer. -3. So we're gonna, so that point we have is gonna be, the input is 1/8, and the output is -3. Okay, so we're gonna put that point on the graph. Okay, let's see what do we get. Red dot. Everybody must do this on your paper. I highly recommend. Okay. I cannot fly to your house to overlook, what you're doing, but please do it for yourself. Okay, that's the dot. Even though it seemed very close to the y-axis, but there is a space, that it's 1/8, right? It's very close, but it's not there. Okay, it's not there. Let's mark that point. Let's mark that point. So mark that point. That point is 1/8, comma, -3. -3. We're going to make it red marking. There. I hope it's turned out to be good. Okay, not too bad, right? So let's look at those points, right? Let's look at those points. Did you guys mark those points? And that's the one point, right? And there's another one. There's this one, right? 1, 0, right? 2, 1, 4, 2, 8, 3. All these points are marked. Now we have two more numbers to calculate. Two more numbers to calculate. Okay, so what do they equal to? Log base 2 of 0, log base 2 of -1. What do they equal to? So let's start one at a time. Log base 2 of 0. What does that equal to? Ellen, do you have an answer to it? What does that equal to? Two, 1. Marcelo's answer, your answer is a 2.1. Is that 2, 1? For this one? Is that what you meant, Marcelo? So you think is it 2.1 or 2, 1? Comma. So this is a 2 point? This is 2 numbers? Is that what you meant? Is that what you meant? It should be a single number. It should be a single number if it exists. So do you mean it could be equal to 2 or it could also equal to 1? How do we figure this out? How do we figure this out? Okay, common one. So that's what you meant, okay? So I'm going to take this out of this table. Okay. I'm going to put it here is how do we figure out? How do we figure out the value for log base 2? What does that equal to? Okay, suppose it equals to triangle. According to the definition of logarithm, this triangle power 2 should equals to 0. Right? So whatever that value is, this number, so if you have a 2 here, if this is a 2, is 2 squared equals to 0? And that is not true. Therefore, it is not 2. It is not 2. Is it 1? Is that equals to 1? That means 2 to the power 1 has to equal to 0. And that's not true either. Do you follow me? So log base 2 0 has, what does it equal to? So the answer you provided 2 or 2 comma 0, that's not true. That's not true. But we know if there's such a number, okay, and this number should make 2 raised to the power of triangle. Suppose that number is triangle, should that equals to 0? Because this is omega, right? This is in the place of omega, and omega now is 0. Now the question is, does such a number exist? Right? We just did it in the recap. We say that 2 to the power x is always positive of any real number. Okay, 2 to the power of any number is always going to be positive. Okay, so this is not possible. So this latter one is not possible. Okay, not possible means that such a number does not exist. If such a number does not exist, and there's no answer to here, no answer here. So such number does not exist. i.e., for the input 0, the output does not exist. Therefore, the input 0 cannot be in the domain. Okay, and what do we say to that? We say it is undefined. 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 You follow me? So this number, you're not going to have a point on the graph, because for the input 0, there's no point, no point. Okay, not defined or undefined. For -1, it's going to be the same argument. Okay, if that equals to a triangle, and that triangle power 2 would need to be equals to 1, but 2 to the power x is always a positive. Therefore, that is not possible as well. Okay, therefore, this one is just undefined. Okay, undefined. Okay, so you're not going to see any dot. We're not going to see any dot on the y-axis or to the left of it. So no point. So there will be no points, no graph. Okay, you're going to see no points on the y-axis, because if you have any point on the y-axis, x must be 0. The input must be 0. And you're not going to see any point to the left of y-axis, because if you have any point over here, that means if you have a point over here, right? And that means your input has to be negative, but input is negative, is going to be undefined. So you're going to have no points. We are going to have no points on the y-axis nor to the left of y-axis. Do you guys follow me? Okay, so the only points we can get are to the right of y-axis. Okay, then these points can keep going, right? For example, you can, I'm going to insert another row. Okay, so I can have like 1 over like 2 to the power of 10, right? And log base 2 of 1 over 2 to the power negative 10, 2 to the power 10 is going to be equals to negative 10. So that point is going to be way lower. Okay, 2 to the power 10, sorry, 2 to the power 10. And the output is negative 10. So that point is going to be way lower. Okay, that point is going to be way lower, very close to y-axis, but never touch it. Maybe it's here, right? And the curve will be the consequence of connecting all these dots. But you can see negative 10 is very low, and this number is very close to 0, but is not 0. Okay, so as a result, if we connect these dots, okay, so now I'm going to connect these dots. So we're going to see log base 2x that picture. Okay, so let's connect these dots. Log base 2 of x. We're going to use a red curve to connect those dots, and that's the graph. That's the graph of log base 2x. You follow me? Everybody? Undefined. Undefined. They are not in the domain. So you can see the domain of log base 2x. X must be greater than 0. X must be greater than 0. The output, though, the output can be negative. The input must be positive. But the output, okay, the output can be negative. This is something a lot of our students doesn't get. Just because the input is positive doesn't mean the output will be positive. And from these examples, you can see the input must be positive. Okay, because if it's again negative or 0, it's undefined. But the output can be negative. So your points can be below x-axis, can be on the x-axis, and above x-axis. Does everybody follow me? Okay. And also, you're going to see some other interesting phenomena here. Okay, you're going to see some other interesting phenomena here. Okay, when we plot the points, you can see that these 2 points seem to have some kind of rhythm. They just, you just switch the input and output, you get the other. What is that? What is that? These 2 functions are also called inverse function to each other. They are inverse function to each other. Okay, and inverse functions, they have an interesting phenomena here. One's domain is the other's range, right? One's domain is the other range. If you look at the horizontal span, right? The horizontal span of the black, right? The horizontal span of the black, right? In the horizontal direction. Okay, if you look at the horizontal direction, right? The curve, the black curve, which is 2 to the power x, right, is always larger than 0. But if you look at the red, the red never go over to the y-axis to the other side. So that tells us that the domain of the red curve is x larger than 0. So the domain here, okay, so let's go back to the table here, okay. We still see the curve, right? The domain for log base 2x, you can see it cannot be negative, it cannot be 0. The domain must be greater than 0. And the range of the red, look at the range of the red. It can go as low as possible. It can go as high as possible. It can go as high as possible, even though it goes to as high as possible slowly, but it will get there. So the range for log base 2 x is all real numbers. You follow me? So this is the information we're talking about here. And next, asymptotes. Okay, asymptotes. They're asymptotes, right? We talk about that this black curve, which is 2 to the power x, will never touch the x-axis, right? We talk about that. So that's x-axis is called its horizontal asymptote. Okay, so let's insert a row. Okay, horizontal asymptote. What is horizontal asymptote? Horizontal asymptote says, well, this curve can get infinitely close to x-axis, but never touched it. It's always has a difference between the curve and the x-axis. And in this case, it's above it. It's above it. Okay. The horizontal asymptote here for 2 to the power x is y equals to 0. That's the x-axis. Okay. So that's the x-axis. i.e., that's the x-axis. Okay, and does the red has a horizontal asymptote? No, this one doesn't have horizontal asymptote, so none, right? It because it's from negative infinity to positive infinity. How about vertical asymptotes? Okay, how about vertical asymptotes? Vertical asymptote. Vertical asymptote it has a similar concept. What it says is that the curve, there's a curve, well, this curve, you see the red curve doesn't touch the y-axis. It could get infinitely close to it, right? We talk about the red dot could get closer and closer to y-axis. We have different input. These are positive input, but it will never touch the y-axis. So for the log base 2x, it has a vertical asymptote, which is the y-axis itself, which is x equals 0, right? And that is the y-axis, right? But never touched it. It never touched it. So this is the vertical asymptote for log base 2x. And of course, this one doesn't exist. It doesn't exist, a vertical asymptote. Okay. And there are two other quantities we're going to discuss. One is X-intercept. And the other one is in Y-intercept. Okay, so X-intercept. And the other one will be Y-intercept. Let's see what they are. Okay, Y-intercept. The 2 to the power x, right? The 2 to the power x is always above the x-axis, right? It never touches the x-axis. Therefore, it doesn't intersect with x-axis. So x-axis for 2 to the power x, there's none. Okay. Let's see, does it have a y-intercept? Yes, you can see the black curve, which is 2 to the power x, does cross the y-axis, and the point of intersection is 0, 1. So 0, 1, 0, 1. So let's look at the log base 2x, log base 2x. For log base 2x, it crosses the x-axis. It crosses the x-axis right here. So it has a x-intercept. Does it have a y-intercept? No, it doesn't, because x cannot be 0. X has, the domain is x must be greater than 0. So it will never cross the y-axis. Therefore, the y-intercept does not exist. Okay, so this is what we observed. And there's other things we can observe. You can see the red curve can go as low as possible, as high as possible. The black curve can go as low as close to x-axis as possible, and the in the other direction can go as high as possible. Any questions so far? So you can see this one picture tell us so many things. Yes, does it tell us so many things? Okay, now, okay, as we get this point, this is 2 to the power x, this is log base 2x. Okay, so I'm going to write it down using, okay, using this. This is 2 to the power x, right? And this guy, I should be using the black. Okay, let me try to be more color toned, right? So the black is 2 to the power x. Okay, and this other one is log base 2 x. And these two curves, you can see there's a correspondence here, right? You switch the input and output, you get the other point on the other curve. Okay, these two functions are called inverse function to each other. And what do inverse function have in common? There's a line of symmetry, and that line of symmetry, I'm going to draw that line of symmetry. Okay, using the color green. A broken line, that's good. Okay, this line is y equals to x. Okay, it's a straight line. It's a straight line. And the curve of 2 to the power x and log base 2x, they are what? They are symmetrical along this line. In other words, if you fold it, if we fold the black and the red along this green line, and they're going to overlap. They're going to overlap. And so this is the common feature of functions that are inverse to each other. And you're going to encounter other inverse functions in time, and they all have similar properties. They all have similar properties, okay? And you can see this by the points, right? 2, 4 on 2 to the power x, 4, 2 is on the other. And 8, 3 is on log base 2x, and 3,8 is going to be on the other. So input output switch, and you get the other one. So that's the basic feature of functions that are inverse to each other. Any questions so far? Any questions so far? So this is the first graph. This is the first graph we will, we do. And it's also interesting to recognize that the domain and range about inverse functions to each other is one's domain is the other's range. Okay, you see one's domain is the other's range. You see that? One's domain is the other's range. Okay. All right. Okay, so that is the first question. That's the first question we did for forgot this is alpha 56. Alpha 56. Okay, first and no, first and second. First and second. Okay, they are inverse to each other. They are inverse to each other. Okay, and next, your turn. Your turn. Okay, we're gonna do this together. Okay, and I'm hoping you're gonna take the lead. You're gonna take the lead. Okay, ready? The next one, we're gonna do number 3 and number 4 together. Number 3 and number 4 together. Okay, number 3 and number 4 together. We know that they're going to be similar. We do, right? We know they're going to be similar, but we have to do it to see, to feel, to experience that similarity. Okay, so let's look at the number 3 and number 4. Okay, so this is alpha 56. Okay, so alpha 56, number 3 and number 4. Okay, we basically going to do the same table. I'm going to do the graph. Okay, so now you guys got to roll up your sleeves. Okay, base 3. Okay, all of these has to be redone. And I'm going to give you 2 tables. I'm going to give you 2 tables. Okay, and you're going to draw the graph. You're going to draw the graph. Okay, so this is one table. Okay, I'm going to give you the table. Okay, I'm creating these tables. So you're going to see some similarities. You're going to see some similarities, and you see how I create those tables. Okay, and you're going to do the details. You're going to do the details. The first table. Okay, we bring the table together. Okay, the first table, of course, now is going to be 3 to the power x. Okay, this is going to be 3 to the power x. Okay. Everything will be redone. Everything has to be redone. Okay, this is for 3 to the power x. And the next table, okay, for the log base 2, log base 3, sorry, the log base 3. On this table, we know the domain is going to be not including 0. Okay, so this is base 3. And all of these numbers will be redone. Wait. Okay, so all of these numbers will be redone. Here. Wait. Sorry about that. Okay, just hold on. I'm gonna get the table. The reason I do this is because I want you to see the similarity. Okay, on the one hand, it saves me some time to type everything. Okay, so now you have this table here. Okay, and that's to graph that's a graph of 3 to the power x. And the next table you're going to work with is to graph a log base 3x. Okay, and I'm going to make adjustment to the table. For 3 to the power x, there's no other adjustment needed. For this one, I'm going to make it as a 3, and this is going to be 9. Okay, and this is going to be 3. Okay. This 1, 3, 9. I can make the table a little bit shorter. remove that. So you guys gonna work on these two tables, okay? These two tables, so everything redone for different base. And I'm gonna do away with these negative. Maybe not. Okay, I want you to experience that these are undefined. Okay, these are undefined firsthand. Okay, so 1/9, 1/3, 1, 3, 9. I make that shorter. You guys know what to do? Okay, 3 to the power x here. So 3 to the power -2 and 3 to the 175%. Okay, so please work on these tables. Okay, so please work on these tables. And over here, 3 to the power -1, 3 to the power 0. Okay, so you're going to evaluate. Okay, 3 to the power of 1, 3 to the power of 2, and 3 to the power of 3. Okay, and you're going to compose these points. Compose these points, right? For example, input a -2, so I put the examples there, and the output is, that's 1/9. 1/9. Okay, so you're going to make up all these other points. And over here, start from here. Okay, I don't want to make your life too difficult. Just do the place, okay, 1/9 here. Okay, so log base 3. You can refer to the notes we've done before. Okay, log base 3 of 1, log base 3 of 3, and log base 3 of 9. And then we're going to make those points. We're going to compose those points. Okay. To do these points, 1, 2, 3, 4, 5, 6. Okay, we'll take care of the others later. Okay, so that input is 1/9. The output is -2. Okay, there's still some blanks. We'll fill them out together. Are you guys working on those? Maybe it's time to take a break, huh? Shall we? Do you want to take a break? Okay, so let's take a break. Come back in 10 minutes. Okay, but you know what to do. If you want to continue to do that, go for it. Okay, so back at 11:40 a.m. Okay, so let's take a break. Let's continue the work, right? You can see the groundwork actually is pretty simple to do. It's just, you know, you can see it's tedious, but we can, you know, just, when we do it, you think about the definition and repetitively you do the same, you do similar things, and that's how you get better. Okay, so for example, it's 3 to the power -2. That's going to be 1/3 squared, and that's equals to 1/9. Right, so that's how we get this point. That's how we get this point. And the next point, of course, that's going to be 1/3. Right, so the input is -1, the output is 1/3. And 3 to the power 0 equals to 1, and we got a 0 input, output is 1. And this one, of course, that's 3, and that's 9, right? And that's 27. That's 27. So now we have input of 1, output 3, input 2, output 9, input 3, output 27. Oops, 27. Okay, this is just to graph 3 to the power x. Okay, we're going to leave these two empty for now. And let's see, we're going to plot all those points. We're going to plot these points. Okay, we're going to plot all of these points. 1, 2, 3, 4, 5, 6. I'm going to plot all these 6 points. Okay, so please get started. Okay, you should have a paper pencil with you. And let's plot these points. So I'm going to set up a rectangular system right there. Everybody, please do this. Okay, this lays the groundwork for our future studies. Okay, so that's the graph. And then we're going to put the points in place. We're going to put the points in place. So the first point, of course, when the input is -2, the output is 1/9. And we're going to make this a black dot. It's a dot. Okay, -9, a -2, the output is 1/9. Okay, even though it looks very close to the x-axis, is actually above it. It's actually above it. Okay, because it's just 1/9. The height is 1/9. Okay, so this height. Okay, this height. Okay, this little height. Let me see. Let me make some adjustment to show you that picture. Okay, there's a difference. I want you to see this. I want you to experience that. Yeah, actually, I made some, you can see there's a little gap, right? There's a little gap. So that gap is 1/9. It's all because of the scale. It's all because of the scale. Okay. So let me make another adjustment over here. So this way you probably will see, but you see there's a more gap there, right? It's all about the scale. It's all about the scale. And this point is -2. When the input is -2, the output is 1/9. Okay. So there's a little gap between that point vertically to the x-axis. So this much, this height is 1/9. This height is 1/9. Is everybody with me? So we understand the picture, we understand the input output, how it's been plotted. Okay, so that's the point. Okay, so let's put the next point in place. Okay, maybe you want to mark it, right? So let's mark that point. Let's mark that point. Okay, so this point is -2, 1/9. And okay, so I'm going to put the points like that. It's a black dot, and it's properly marked. It's properly marked. Okay, the next point we're going to do. So you guys, please do it along with me. Okay, so we're going to add another point, which is -1 1/3, and I'm going to make it a black dot. Okay, that dot, of course, is -1, 1/3. So let's mark that point as well. Okay, I'm going to try something new here. So if we can mark it better. Okay, so -1, 1/3. Okay, so I'm going to use polar, so maybe 45 degrees. And this is negative -1. And over here is, let me put it that way. Okay, I'm just experimenting with this software to hopefully give you a better viewing experience. There. Ah, it worked. Okay, so the input is -1, the output is 1/3. Okay. Next one. So keep plotting the points. Keep plotting the points. Okay, maybe I can even make this one 45 degrees to see how that looks. Right? No. Maybe I should make that a little bit closer. A little bit closer. There. Is that better? Okay, it's not too bad, huh? Maybe 3. Okay, that's better. Okay, so keep doing that. 0 0.1, 0, 1, 1, 3. So we're going to put every one of these points on the chart. 0, 1. Okay, and that point is going to be 0, 1. And 45 degrees seems to be fitting. I need to adjust the fonts. Right? The fonts sometimes is just exaggerated, too big. There. Let's see if that's better. Right, 0, 1. That doesn't look very good. Okay, I don't like it. So I'm going to just move up a little bit. But when you plot those points on your picture, just make sure it marks nicely. Okay, it marks nicely. You can see why I spend all this time to show you the proper picture. And when you mark those points, you want to make sure your teacher or whoever reads your paper see the points very well marked. Okay, very well marked. It's very, very important. Okay, so my last attempt. Okay, 0, 1. And next is going to be 1, 3. 1, 3. That dot, and we're going to mark it. 1, 3. 1, 3. Okay, and the fonts italic, and let's see how that goes. 1, 3, right? 1, 3. And 2 more points. 2 more points. Sorry, where did I go? 2, 9. 2, 9. 2, 9. I need to adjust the scale. Right? So I'm going to put the point in place. It's a point, and we need to mark it. 2, 9. 2. And I can make 45 degrees. 2, 9. 2,9. That fonts need to be changed, right? The fonts need to be changed. Otherwise, it's just too big. Through this experience, we lay the groundwork. Okay, and last point, of course, when input is 3, the output is 27. And you can see the framework I put here doesn't have enough space to hold 27, so I have to make some adjustment. And let's make the adjustment necessary. Okay, so I'm going to put the point in place. You can see all of these work, all of these groundwork you do is going to benefit you. Okay, so this is a 3. My input is 3 and 27. And so now here, okay, and make the fonts proper. And just make sure we mark those points in the proper way. That's 3,27. Okay, it needs some adjustment, but I'm just going to pass this time. Okay, I'm going to pass this time. Do you guys follow me? So can you imagine we connect the dots? What happens if we connect the dots? We're going to get a curve, and that's the curve for 3 to the power x. Okay, so that's how the curve is made. I promise you don't need to do this every time, but if you just do it at the beginning of learning these functions, learning these curves, you just do it a few times, do several of them, and then you have it. You have a good foundation. You have a good foundation. Okay, so now let's connect the dots. Okay, let's connect the dots. It's 3 to the power x. Okay, and connect the dots. And that's the curve of log base 3. I'm sorry, the 3. That's the curve of 3 to the power x. That's pretty easy, right? It's pretty easy. And next, we're going to graph the other one. We're going to graph the logarithm, right? Graph the logarithm. Of course, we still have some empty space. Okay, we still have some empty place to fill, but that's okay. We're going to come back to it. We're going to come back to it. Okay. So what is a log base 3 1/3? What does that equal to? We know that 1/3 equals to 3 to the power of -1, right? By this time, you probably have figured out how I have chosen the point the way I did, right? The way I chosen the points, because I want to make the calculation easier in choosing the points. So now this is going to be -1. So the next point. Okay, so that input is 1/3. And the output is -1. Okay, and input and log base 3 of 1, that's a 0, right? And that's going to give us another point, input of 1, output 0, sorry. Okay, input of 1, output 0. And log base 3 of 3 equals to 3. I'm sorry, equals to 1. What a terrible mistake, right? So 3, 1. Okay, input is 3, output 1. Last but not least, the input is 9. The output is 2, because here we get 2. Okay, 9 is 3 squared, right? 9 is 3 squared. So these are pretty familiar points. So next, we're going to put the points in the graph. I'm going to put the points in the graph. Okay, in the same graph, Okay, in the same graph. You ready? Now, starting from the first point. Okay, starting from the last point. It looks like I need to make some adjustment, right? because the X direction, I only have 5, I need 9. So I'm gonna make some adjustment. So this is gonna be 10. Okay. So now if I want to put that point in the graph and with a red dot, this time it's a red dot. There. Okay. And I do want to make some adjustment because this picture, the scale wise, is a little bit too much for us to manage. So I'm going to make that point disappear. I'm going to reduce the scale. I'm going to make adjustment to the scale so we can see better pictures. Okay, so here I'm just going to make it 10. Right, so that's 3,27 is going to disappear, but it's not going to affect the whole picture. It's not going to affect the whole picture. And wait. Oh, wait. Here. Okay, I did it on the wrong place, but it's okay, not a big deal. So I'm gonna make this 10. Right, so this way, when we see 9,2, the point is better reflected. So let's mark that point. Okay, 9,2. Input 9, output 2. So 9,2. And we're going to have the fonts red, right? And 45 degree. Let's see how that looks. There, 9,2. It's not ideal, but you can tell, right? So I'm not going to spend too much time on, perfecting it. So the next point, 3,1. 3,1. Okay, red dot 3,1, and I'm going to mark that point. You see, it's systematically done. Okay, 3,1, 3,1, and 3,1. Maybe I'll make it a little higher, huh? So hopefully that shows better. The red dot marked 3,1. Okay, and 1,0. You can see, graphing is just we do this point by point. And with technology, and these days, we really don't have to do all of this work when we want to get a whole graph, but you have to know how it's been done. So this is the groundwork we do. So in the future, you totally know how it's been done. It's just one by one. Okay, so 1, 0, red dot. You got the hang of it, right? You got the hang of it. 1,0. So you can see if you connect the dots, right? So now let's look at 1/3 as the input. The output is -1. So where does that point go? Where does that point go? Right? It's a red dot. You can see the output can be negative. Right there. Right there. And let's mark that point. Let's mark that point. Okay, let's mark that point. It's 1/3, right? 1/3, comma, negative. -1. And the fonts, red. And color. Okay, I'm trying this to see how that works. Oh, 1/3 and -1. And one more point, 1/9. Okay, 1/9. We're gonna plot that dot and plot that point. It's a red dot. And then mark it, of course. okay? And the input is 1/9, the output is -2. -2. Okay, so we mark those points properly. So from the color, we can tell which point is on which. Even though this red dot is very close to the y-axis, it's not sitting on the y-axis. It's because the input is 1/9. So it's very, it's a number larger than 0, very close to 0. Okay, so guess what? Guess what happened if we connect these red dots? It's log base 3. And we're going to have a red there. Do you guys see that? You see this pair, number 3 and number 4, they're very similar to the first pair, right? Number 1 and number 2. Number 1 and number 2, they're very, very similar. And we also see some other interesting figures, okay? Then we're gonna be filling in the gap, okay? We're gonna filling in the blanks. Now, in both directions, okay, if we look at the black curve, in the direction, if we choose values to the negative infinity, you can see the black curve is going to go down and down and down, forever close to the x-axis, but never touched it. Okay, and we can see this from the numerical calculation. We can look at this from the numerical calculation. For example, if I have a -10, right? And then you're going to be evaluating 3 to the power of -10. 3 to the power of -10 is a number larger than 0, but very close to 0. It's larger than 0. So this point, right, as input equals -3, the output is 1/3 to the power of 10 is going to be a point so low, so close to, so that the point is probably, let me just give you like a little indicator. It's probably somewhere here. Okay, very low, very close to 0, right? But never touch the x-axis. If we have input at 1000, it's going to be even further to the left to -infinity. So the entire curve is always above x-axis. Okay, the entire curve is always going to be above the x-axis. Okay, so I want you to see the point. Okay, 3 to the power x this time is 3 to the power of 1000. Okay, 3 to the power of 1000 in the denominator. So this number is larger than 0. It's going to be to that direction. Okay, very far further away, right? Very further away. Okay, very close to 0, but it's not equal to 0. So that point is something like that, -1000. Okay, and the output is 1/3 to the power 1000. Very small number, larger than 0, but larger than 0. So this demonstrates that the entire picture, okay, the entire picture is above x-axis. Okay, they get infinitely close to x-axis, but never touched it. Never touched it. Okay, so now let's look at the log base 3x. Okay, log base 3x, right? When we get in this direction, right? In this way, right, when input is getting closer and closer to 0, and the point is going to get infinitely lower. It's going to be infinitely lower, right? The points we're getting is going to be getting lower and lower getting very, very close to y-axis, but never touched it. And for this point, okay, for this point, for x equals 0 is undefined. For the same reason, undefined. So these points are undefined, undefined. These points don't exist, okay? On this point, however, right, if we have 3 to the power 10, 3 to the power negative 10, sorry, 3 to the power negative 10, and the answer, of course, is negative 10. So that's a point way below, okay? So that point was the input of 1 over 3 to the power 10. The output is a negative 10. So the point is way below. So now let's, with these pictures in our, in our presence, okay, so let's work out these table. Let's work out this table. Domain for 3 to the power x, it can be any real number, negative infinity to positive infinity, right? The range 3 to the power x is always larger than 0, no matter what x is. And these two are inverse function to each other. So the horizontal asymptote here for 3 to the power x, that's going to be y equals 0. That's the x-axis, right? That's the x-axis. X-axis. And the vertical asymptote, we have a vertical asymptote, none. Okay. And x-intercept, no x-intercept, none. Okay, so the black curve never crossed the x-axis. It get infinitely close to it, but never touched it. Y-intercept, yes, 0, 1. That's the point right here, right here. Okay, okay, right there. Okay, oh, terrible, terrible. Let me do it again. Okay, so that's the y-intercept. That's the y-intercept. Okay, are we good? All right. So let's continue and look at the red curve. Red curve is log base 3x, right? The domain, x must be greater than 0. And the range, all real numbers. You see, one's domain is the other's range. One's domain is the other's range. Similar, right? Similar. And next, okay, horizontal asymptote, there's none. Okay, there's none. Vertical asymptote, yes. The red curve will never touch the y-axis, okay? So that a vertical asymptote is x equals 0, which is, that's the y-axis. That's the y-axis. Okay, and x-intercept, yes. Okay, the curve crosses x-axis. Okay, 1, 0. The y-intercept doesn't exist because it never crossed the y-axis. Okay, so that's none. So once again, when we see these two curves, right? They have some kind of symmetry going on there. They have some kind of symmetry going on there, isn't it? Right? You see, this is y-intercept, x-intercept. They just switch input output, and these two switched, right? 1, 3, 3, 0, 2, 9, 9, 3. There's some kind of symmetry there, and the line of symmetry is once again, y equals to x. Okay, so that's the line of symmetry. Okay, so this line of symmetry is y equals to x again. Right? Do you guys see that? Yes. Okay. So very similar to the first pair, 1 and 2. And I'm going to leave 5 and 6 for you, and we're going to do 7, 8. We're going to do 7, 8. 7, 8 is a must do. It's a must do. After we've done 1, 2, 3, 4, let's do 7 and 8. I'm leaving number 5 and 6 for you. Okay. So please do them. Okay. For your benefit. By this time, we have noticed a lot of interesting facts, right? The symmetry, if we compare, okay, so before we do the E, okay, so let's recap, right? That's a recap. I'm going to bring the facts, that's the important facts, right? These two, okay, these two for base 3, okay, so I'm going to make the fonts a bit much smaller so I can transport, okay. I'm making my transportation a little bit easier. For the 2s, base 2s, we've done that. Look how similar they are. Look how similar they are, right? So this is for 2 to the power x log base 2x, domain range, right? And for 3 to the power x log base 3x and domain and range and everything. Don't they look similar? Don't they look similar? Right? In fact, they're tables. You can, these two tables, okay, let me put them side by side. Okay, I'm going to put these two tables side by side. What am I doing? Hold on. Let me do this. Tables side by side. Picture side by side. How about that? Okay. Picture side by side. Table side by side. I want you to compare. Please compare. Tables side by side. Tables side by side. Yeah. Picture side by side. What do you see? What do you see? Anybody want to make some comments? Anybody want to make some comments? They're very similar, right? They're very similar. So next, with these behind us, we're going to work on the E. We're going to work on the E. E function, base E is very, very important. Okay. It's important not only in the field of mathematics, it's also in the field of finance. It's also important in the field of economics, engineering. Okay, it's a very, very important function. So we need to graph them, even though the picture will be similar. We expect similar pictures, but we must do the points. Okay, so let's do the E. Let's do e to the power x and ln x. Okay, ln x. Ln x it takes some time for us to get used to it. Okay, in fact, when I'm teaching pre-calculus class this semester, a lot of our students is not quite used to ln x. So I want to give you guys a head start. Okay, I want to give you guys a head start. So the sooner you get to work on this, the better you will be. Okay, so I'm going to make this table. We're going to make a similar table. Okay, we're going to make a similar table, except this time it's e to the power x, and this is going to be ln x. Domain range, we're going to fill them up. We're going to fill them up. I know they're going to be similar. They're going to be similar. Okay. And then we're going to make the table. We're going to make the table for graphing. The table to graph. Okay. The table to graph. Okay. This is the log. We're going to do the log. Okay, we're going to change. I'm going to make changes. Okay, before I make that change, let me just bring those calculations, and you see the similarity. I do want you to see the similarity. But we have to do the work. We have to do the groundwork. Okay, so let me do this. So those are the logs, okay? And I'm going to find the power. Where is our power? We did the power, okay? We did the power, it's right here. Here we go. Here we go. There's no rush. Okay, so plotting the points. So plotting the points. And of course, this time it's e to the power x. Okay, it's e to the power x. Everything will have to be redone. Okay, the input, I'm still going to choose the same input, no change. But for ln x, however, the input will be changed. The input will be changed for our convenience. Okay, for your convenience, for my convenience. Okay, so all of these is going to turn to ln. Okay, all of these will turn to ln. We don't need the other table anymore. Okay, I'm going to make the table a little bit more compact, maybe a little shorter. Okay, so here I'm going to give you e to the power of 2, right? So this way you will see how I compose the table. And this table, this row, I'm going to delete. Okay, and this is 1, and this is e, and this is e squared. Okay, I'm going to remove this row. Delete. Oh, you can see there's some simplification here, right? Still, these are undefined. And now your task, okay? You're going to do e to the power of -2, e to the power -1. Okay, you don't need to get the numerical value. You don't need to get the numerical value. Okay, I'm going to show you. So this is e to the power 2, e to the power 1, e to the power 2, e to the power 3, if you will. Okay, and over here, and this is going to be e to the power of 10. Okay, and over here, you're going to do the ln. Make the fonts a little bit larger because sometimes the negative signs are not visible. Okay, so you have ln, of that guy. Okay, 1 over E. Okay, you please do these calculations. Okay, so you can be better at logarithm. You can be better at logarithm. 1 over E. So the place I have a field, and it's the work you must do. Okay, so ln E squared. Okay, and then we compose the input output. We leave these blank. We know these are undefined. Okay, undefined. Okay, undefined for the same reason. For the same reason we have addressed before. Okay, undefined, they don't exist, right? Does not exist. Okay, so I'm just going to put that to emphasize. And this one you can do e to the power 10. Okay, I've chosen the numbers to be easy to calculate. So don't worry about using calculator at all. Don't need to worry about using calculator at all. Okay. On this side, I just want you to do this. Okay, it's going to be 1 over E squared. And the point is going to be -2. The output is 1 over E squared. Okay, and the second point is 1 over E. And that point is going to be -1, 1 over E. Then you say, what is 1 over E? Don't worry about it. Okay, 1 over E, you just approximate it. Okay, it's like 1 divided by 2.7. You approximate that point. 1 divided by 2.7 or 1 divided by E is a number between 1/3 and 1/2. Okay, that's all you need to know. You just estimate. You just estimate. Try to learn how to estimate. 0, 1. And over here is 1, E, 2 E squared. So we get these points. The last one on this side is 3, E to the power 3. Oops, sorry. Okay, on this side, what do they equal to? This should be -2, and that equals to -1, and that equals to 0, and that equals to 1, and that equals to 2. Okay, we've done these things before. So now we put them in the table form, and we can get some graph. We're going to get some graph. So the input here is 1 over E squared, comma, -2. Right? And this one is 1 over E, comma, -1. And the next point is 1, 0, E, 1, E squared, 2. And we're ready to plot, right? Are we ready to plot? We're ready to plot the points. We're ready. We're going to plot all of these points first. We're going to plot all of these points first. So I'm going to push that table to the side. I'm going to push that table to the side. Okay. So now we're just going to do this table, right? We start the rectangular system. And we want it to be next to our table. Okay. And making some adjustment on the scale, Okay, so in the Y direction, I see I need to just to make some adjustment. Make a -2 then. And over here, maybe 4. On this side, I'll make it -4. The other side, I'll make it 10. Right? Okay. So it each has its scale, and I'm going to plot the points. And this point, okay, this point, let's see, where do we have for that point? That point, I'm going to make it a black dot right there. Okay, above x-axis. Okay, and we're going to mark it. I'm going to mark it. Okay, so I'm going to put the second dot. I'm going to mark these two together. We're going to mark these two together. There, another dot, right? So we're going to mark these two together, and you guys must, I highly recommend you mark it with me. Okay, so this is E, this is a -2, and the E 1 over E squared. E squared. 1 over E squared. Okay. And mark at a -2, and I'm gonna use polar, so maybe 80 degrees, 90 degrees. Let's see what happens. You see the dot? Okay, -2 input, output is 1 over E squared. That doesn't look terribly appealing. So I'm going to make this 1. Would that look better? Ah. Where's the fonts? Well, maybe make it 2. Would that be better? There. Thank you. All right, so that's 1 point. Okay, so let's mark the other point. Let's mark the other point. The other point, if you may, the input is -1, the output is 1 over E. And so make it that way. The second point. I need to turn it. I need to turn it. So make it 90 degrees. This looks fun. All right, so that's the point, right? And the third point, 0, 1. You guys can go ahead, okay? You don't need to wait for me. You don't need to wait for me, but please do make sure you have experienced this. Okay, you have experienced this. It's very important that this is your groundwork. Okay, I'm gonna make this time 45 degrees to see what happens. Okay, just marking the points. Marking the point, 0, 1. Oh, that doesn't look very good. I'm going to make some adjustment. Wait. Okay. I'm going to make some adjustment. Okay. So maybe this 45 degree. Show up nicely. Oh, that's terrible. That's terrible. There. Oh. 0, 1. It's not too bad, but it's not the best. Okay, but I'm gonna just move on. Okay, it doesn't have to be perfect. It doesn't have to be perfect. So 1, E. 1, E. We're gonna mark that point as well. Did I plot the points 0, 1? Yeah, okay, I did. So 1 comma E. So when input is 1, the output is E. Okay, and marking that point, 1 comma E. We got 1, maybe make this is 3, and 90 degree, and the fonts there, 1 comma E. It's not the best, but it's pretty good. It's pretty good. It's not the best. Okay, I could we'll move up a little bit, but let's stop. Make it try to be the perfectionist, right? Being perfectionist is not. It takes a lot of time. So this works. This is good enough for us. So this dot, and then we're gonna add this point to 2 comma E squared. Okay, so this is 2 E squared. E is between 2 and 3. So E squared is between 4 and 9. So if I put a 5 there, and that should do decent work. Okay, I'm not asking to do a perfect work. Okay, let's see there. 2 comma E squared. It could be better, right? So I'm going to make it closer to it. As you can see, plotting these points, it's really the labor of love, right? It's really the labor of love. And let's see how that works. It's not too bad. It's not too bad, right? The last one, actually, I'm not going to do it. I'm not going to do it. But I highly recommend you do. It's going to be way up. It's going to be way up. Okay, so I think this is good enough. And next, we're going to draw the picture. We're going to connect the dots. Okay, so we're connecting the dots. There. That's e to the power x, right? That's e to the power x. And next, guess what do we do? Of course, we are going to graph ln x. Ln x. Are you guys ready? Ln x. We're going to graph it in the same picture. In the same picture. Okay, we've done the calculation. We've done the calculation, right? We got these dots. Are you guys ready to plot these points with me? Let's do it. We're only going to plot. Let's plot the 5 points. Okay. Start from e squared. We start from the bottom. Okay. You can start anywhere really. So I'm going to start from the bottom. This dot is going to be that. I'm going to make it red. Okay, that dot. It's off the chart. What happened? Well, I didn't have enough x value, so I need to make some adjustment. Okay, so the x value, I'm going to make it up to 10. And there we go. We got the points. We got the points, right? And this point is e squared as the input, comma 2. E squared, comma 2. Okay, so e squared, comma 2. Okay, e squared, I'm going to make it something like that. Okay, and so maybe 90 degrees. And the fonts, I'm really just showing you the groundwork. And I hope you guys will do the groundwork too. Okay, are you guys doing that? So please do, okay? Your patience will reward you tremendously. Just do this, just do it. It's a red dot. I'm gonna mark that red dot, which is E, comma 1, input E, output 1 for ln x, right? So I'm going to use 1 over here, get a 90 degree. There, the red dot. E comma 1. Okay, E comma 1. So we have 2 dots already, right? 1 comma 0. 1 comma 0. Let's see, where does that sit? It gets easier and easier, isn't it? And that means you are getting better. Okay, you are getting better. Okay, so 1 comma 0. Okay, you are getting better. That's why. It gets easier because you are better. One comma 0. Oh, this is a little bit off. So I need to make some adjustment to that 1 comma 0. Say, this is 0.4. So that would do it. 1 comma 0. Okay, that's fine. That's fine. 2 more points. 2 more points. The input is 1 over E. And the output is negative 1. Okay, that red dot, let's see where it is. It's here, right? It's here. So let's mark it. Let's mark it. Okay, we're going to mark that point. And the input is 1 over E. The output is negative 1. And we're going to mark that point in the picture. There's a red dot. There's a red number. There's a red number. See how that goes. 1 over E comma 1. Okay, it could be better. It could be better. Right? It could be better. So how about 1? That's a little bit better, right? One more. So we already got the picture, right? We got the picture. Got those dots, red dots, right? And now we're going to mark those points. So this is 1 over E squared, comma, negative 2. And that point is negative 2. And make it just a little bit tilted. Red dot. How about that? How about that? But that second one is a little more. That's last one is not so amazing. Okay. I think I should just keep it simple, isn't it? I should just keep it simple. Let's not do the polar, just do that. Maybe 0.5. Isn't that fun? No, this is bad. This is bad. I hope you guys are not too tired. I hope you guys are not too tired. Okay, this is better. So we got the dots. We get 5 dots. So shall we connect the dots? So let's connect the dots. Right, ln x with the red curve. Look at that. Look at that. Doesn't that look familiar? Doesn't that look familiar? So you can imagine a lot of the properties, even the blank ones, we can feel it, right? But we totally understand what it means now. And for example, on the red curve, we have the input here and the output is negative 10. So it's a dot way below, right? It's way below. So you can see the 2 red curves and there's these correspondence. Still similar. Look at these correspondence, right? And look at these correspondence. I'm going to just to for you to see that what we have observed before, right? And you switch the input and output and you get these dots. And with that similarity to what we did before for number 1, number 2, 3, 4, and needless to say, if you do 5 and 6, you're going to see similar. But if you notice how the points are chosen, if you notice the point, how the points are chosen, and these two functions obviously are inverse function to each other. In other words, and they will be asymmetric. There will be a line of symmetry. And that line of symmetry is going to be the same. Okay, so this line of symmetry is exactly the same as we have done before, right? So are we ready to fill out that table about domain and range and so on and so forth? I'm sure you are. I'm sure you are. Okay, so let's do it. So we take this picture, okay, and we are going to fill out that table. We're not going to do this anymore because you know that this picture is going that direction. It will never touch the x-axis, right? So once again, let's just mention this anyway. As x getting to infinity, x get to negative infinity, and these values, right? E to the power of negative 10 is going to be a number very close to 0, but it's larger than 0. Okay, so that point is going to be way over there to the left. But the output is going to be above x-axis. The same thing is true for e to the power of a negative 1000. Okay, so that point is going to be above x-axis as well. Okay, so this just gives us the visual and the numerical concept, right? The input is negative 1000 and the output is going to be above x-axis. So this will illustrate to us that e to the power x is always positive, no matter what the real number x is, right? So now we have done the groundwork. Let's come back here. I'm going to bring that picture we worked so hard for next to it, right next to it. Okay, domain, of course, all real numbers for e to the power x. And the range, e to the power x, is always positive. Okay, and one's domain is the other's range, right? So in the domain for ln x, x must be greater than 0, and the range for ln x is the same as the domain to e to the power x. You can see one's domain is the other's range. So that relationship is true once more, right? Are we good? I know you guys are a little tired. Just don't give up, okay? Don't give up yet, okay? Let's continue on this table. Horizontal asymptote for e to the power x, which is the black, is still y equals to 0, which is still the x-axis. The vertical asymptote, none. It doesn't exist. Okay, so x-axis. Now x-intercept, none. It never touches x-axis. The y-intercept, however, is going to be 0, 1. 0, 1. Next, okay, for the ln x, horizontal asymptote, none. Vertical asymptote, yes. That's the x equals 0, which is the y-axis. x-axis. X-intercept, yes, it intersect with x-axis at one point. Y-intercept, where's the y-intercept? None, because it doesn't exist, right? It never crossed the y-axis. The red curve never crossed the y-axis. Now, okay, near the end of the class, okay, we're going to do the comparison for all three sets, okay? We just did e to the power x and ln x. Okay, so I'm going to make the fonts just a little bit smaller. Okay. So that guy, right? And it's a picture is right here. That's the picture for the two, right? That's a picture for the two. And the prior to this, okay, prior to this, we did a recap, right? We did a recap for 2 to the power 3 and so on and so forth. So bring these two tables here, we have done, right? And the two pictures we have done, if we put them next to each other, what do we see? What do we see? The pictures, this is for 2 to the power 3, right? This is for, I'm sorry, 2 to the power x and log base 2x. 3 to the power x, log base 3x. E to the power x, log ln x. And their domain, range, intercept, and everything, they are exactly the same. They're exactly the same. Do you agree? Do you agree? Do you see that? Right? Domain, let's compare one by one, right? Compare one by one. So can we condense all of these in one table? We sure can. We sure can. Can we condense them into one table? If you look at table, the first two, right? Domain, range, everything. Same, right? So this is going to be 3, the true for 3 to the power x is going to be true to e to the power x about domain and range, right? So all three, they're all greater than 0. Intercept, right? So this is going to be true for log base 3x, ln x, right? The range, domain, they are all the same. So these three tables now is condensed into what? Into one. How about the pictures? We're going to bring all the pictures together. We're going to bring all the pictures together. Okay, we're going to bring all the pictures together in one picture. Right? We're going to put them all together. 2 to the power x, 3 to the power x. And of course, there are some differences. That's why I want to put them in, put them together, right? So starting from e, well, this is, I'm sorry, 2 to the power x, right? 2 to the power x. Three to the power x. So now we're going to put them all in the same picture. The you know, there will be some minor differences on the actual points. There will be some minor differences on the actual points. Okay, so what I'm going to do is I'm going to graph all of these in one picture. Okay, we still have time to do that. Okay, so 2 to the power x. Guess what? Guess what I'm going to do? I'm going to do this. I'm going to keep the e to the power x. Okay, because this is the picture we regard it as the most important. E to the power x, sorry about that. Okay, e to the power x, right? This is e to the power x, this is ln x. Okay, in this picture, I'm going to draw 2 to the power x. I'm going to make this what color? That make it purple. That's 2 to the power x. Okay, that's 2 to the power x. Let's mark it. It's very important to mark. Okay, e to the power x, and this is 2 to the power x. How about 3 to the power x? Right? 3 to the power x. 3 to the power x. Let's see what color I'm going to give it to. This bright green. The bright green. The bright green. The bright green is 3 to the power x. Is that clear, everybody? Okay, so the current one is ln x. Okay, so this is ln x. Okay, ln x. So we have that ln x. Let's graph the log base 2x. Okay, so log base 2 of x. I'm going to make it purple just so you can see their correspondence. Okay, I hope that helps. Okay, you can see that's log base 2x. Purple. So log base 2x. Okay, last but not least, log base 3x. Log base 3x. I'm going to make it a color green. Green. Okay, so let's mark it. Okay, that green is log base 3x. Okay, so their relative positions are like that. Domain range, they're all the same. Same domain, same range, same relationship. But it's important that we have done it. We have done all three. I hope you guys have done all by your own hands, and this will help you tremendously. This lays a very good foundation for our future studies. And I think that's all for today. We have done some really hard work. By hard work, I mean, it takes a lot of patience. The work itself is not that difficult, but it really takes a lot of patience to get these done. Okay. And I applaud you for doing this with me. And I hope you do it, because I will assign these as homework. We didn't do 5 and 6, and it's you guys' turn to do 5 and 6. Okay. And I will give you homework for you to do the 5 and 6 and to complete the table and so on and so forth. And I hope that will really help us to understand these graphs. Okay, they are going to be used in your future studies, Okay, so now for the remaining of the time, I'm going to take some questions. Any questions you may have? So for your homework, okay, you should do all of them, in particular number 5 and 6. Okay. Any questions? Any questions? Alan, Francisco, Marcelo? I hope you're not too bored. To me, doing these groundwork to lay your good foundation is very, very important. Okay. And we should remember today's date. This is May 17th. And this is the day we did all the graph of no question. Okay. Just remember this date. Okay. May 17th, 2021. In the future, if you need these pictures and graphs and the details, you may want to come back to visit these lectures, okay, to visit these lectures. And lots of work, lots of patience, okay? The level of difficulties of doing the detailed work is not much, but it takes so much patience to complete, okay? And we have gained much insight. And you will see some of these insights will be useful in the future. I think that's all for today. And I will see you guys on Wednesday, and homework will be assigned to you. And have a great day. See you on Wednesday. Thank you. Thank you for coming.